So what I'm going to talk about is some innovations, some recent innovations from Australia, at least 6 months ago anyway. As I said, a bit on yield estimation, a bit on an application looking at powdery mildew, and the use of drones in agriculture and viticulture. Estimation's important. It's an expensive, it has some expensive impacts that resonate throughout the whole production chain. It's important in terms of the intake of your fruit, allocating fermenters, organising tanks, buying oak, managing your stock, organising labour, ingredients and marketing. It was estimated a while back that the cost of inaccurate forecasts is around about $100 million a year in Australia. So just imagine you're a group of winemakers in a room and I asked you the question, what would you like from a yield forecast in terms of plus or minus percentage? What do you think winemakers would come back with? Any takers? That's what they all say. They all want plus or minus 5%. Every now and again a winemaker will say 0%, but most of the time it's plus or minus 5%. We can get plus or minus 5% close to harvest using a similar approach to what James talked about yesterday, destructive harvesting of segments. Essentially it's a representative sampling exercise. Can we get it before flowering? Can we get it after veraison? We think probably the best we can do before flowering, based on counting inflorescences, is probably plus or minus 20%, maybe a bit better. After fruit set, that improves a bit because your flowers have turned into berries and there's more certainty, maybe plus or minus 15%. And mind you, this is if you follow a manual system rigorously and you pay attention to bias and sampling intensity. Close to harvest you can get plus or minus 5%. It's simply a sampling exercise. I think, are people going to get these slides, Michelle? Are people going to get these slides?
I don't remember.
Okay, well there's a website there. This is an excuse to put up one of my early papers. I think this is probably one of the first papers that was produced in viticulture and image analysis. It was very primitive. It was kind of back in the day, and it was there just to show that it had potential. Things have moved on a fair bit since then. The advantage of image analysis that it allows you to have a much higher sampling intensity. So you can collect a lot more samples, a lot more numbers. It will reduce costs and labour. And importantly, it actually eliminates bias, and it's actually difficult to do anything in the vineyard manually without introducing bias. So there are a lot of good reasons for why you would pursue an image analysis system in terms of forecasting. This is a project that I led before I left. It was with the Department of Primary Industries in New South Wales, the University of New South Wales in Sydney, and the big wine company in Australia, Treasury. We looked at collecting images using various different cameras and some hyperspectral cameras, from different devices in the vineyard and using different methodologies. This work is not on its own. It has been happening with Nushki at Cornell for some time now, and it's kind of a similar approach with some differences. So, sensing inflorescences and berries, really, it's a work in progress. The issue is that, and there are various ways to deal with it, and I was chatting to James about it just last night, but berries obscure berries, foliage obscures berries, collecting images with things like contrast and light's important. So it's a work in progress. Don't expect anything next year or the year after. But there are some good applications that came out of some of our work. One of the students produced a very nice flower counting application on the iPhone. I think there are also other efforts to do this. I know Javier Tardaguia in Rioja has also produced a flower counting application. This will be commercialised fairly soon. One of the nice things one of our students did is produce a berry counting application. It's iPhone and Android. It will reconstruct the bunch within plus or minus 5%. It will give you the number of berries. It will give you an average berry diameter, and also the porosity of that bunch, which might be important for disease management. So this is something you can take into the field. You know, one shot, and you can get all that data in about 3 seconds. So I think this is quite a nice output of the project. I'll leave that there. There are many ways to skin a cat. Is that a common saying in France? Many ways to skin a cat? Perhaps Australians are barbaric. Yeah, you can actually look at the weather. We've known for a long time that the weather, particularly in the previous spring, has a big impact on yield in the following season. All this is, for those of you who can't read the English, is it's a yield trace. So there's yield going up and down in a Shiraz vineyard near Wangaratta. Underneath that is temperature in the previous spring, and you can see it's very closely related to yield going up and down. So here's another project from Australia. It's Steve Van Slater from Macquarie University. Steve's a biochemist who now trades as an ecologist, but he's also into neural networking and self-learning models. And that's the model that Steve used. I actually arranged for him to be supplied with an awful lot of data, because the more data you throw at these models, the better they are. That's another conversation James and I had last night. So data from a few different wine regions. We're actually giving Steve more and more data, and he's seeing that this is a bit old. He's doing a bit better than that now. If you provide the model with the geospatial coordinates, it's very important, because the Australian Weather Bureau will give you fairly good fine resolution interpolated data these days. 5 years worth of yield. Temperature at bud burst in the current season and the previous season, and temperature at flowering in the current season and previous season. You can actually get to within about plus or minus 12% at flowering. I think that's terrific. This at the moment holds for me more promise than the image analysis. We'll move on to powdery mildew now. This is an app produced by the University of Adelaide, Barbara Hall's group. I think it's a really good app, so I don't know whether you played around with it, but I think it's free. It's completely free. It's iPhone or Android. What it does is, that's what it looks like. You take it into the vineyard. First of all, it trains the user in how to identify powdery mildew, because that's very important. Then it will allow you to self-calibrate your identification of powdery mildew. So you'll go through various sort of self-learning exercises in the application that will actually calibrate you to, if it's 2%, to be close to 2%, or if it's 5%. Now, this is important for whether fruit's rejected or not, whether you select a bunch to harvest, for instance, or whether you just want to assess powdery mildew in the vineyard. And it will evaluate a cumulative evaluation of powdery mildew across the whole vineyard block. So at the end of all your visual assessments, you'll end up with a number that tells you the extent of powdery mildew in the block. I think it's a very good application. Could you use it for botrytis? Probably. That's a very good site for a lot of help, a lot of useful information about how you use the application. And when I went into there, it didn't cost me anything, and that was from the UK, so I presume it's free of charge. How's my 15 minutes going, Michelle? He's asleep. I'll talk a bit about drones now. This guy is called Mr. Roy. He is a big strawberry farmer in Queensland. Now, he's big, but he grows a lot of strawberries. That's what I mean by he's a big strawberry farmer. And he puts, he's very interested in predatory mites, because two-spotted mite's a big problem in his strawberry fields. And he used to get workers to go and put out mixtures of predatory mites into his strawberries, but when he was up in his helicopter one day, he noticed that instead of doing the job, they were actually in the shade having cigarettes. So he decided he would fix the workers, and he would use his own drone. So he's got that drone there, and what it does is it actually delivers predatory mites to strawberries. So he's worked with an entomologist at the University of Queensland, I think, that looked at what you needed to do in the mixture, how you kept these colonies alive, how you delivered them to the strawberry canopy. So I think that's an example of a different kind of application for drones. In terms of drones, in Australia at the moment, there are some consultants that are using them to assess the amount of bare fruiting wire. It's important in terms of the progression of something like trunk disease. But in terms of your production system, it's just important to know generally how much of your vineyard's actually non-productive. That's an important question. Is it going to replace planes for NDVI? Possibly, possibly not. I think that's my 15 minutes. So any questions later? Thank you.